Class example 1.6.1. This example is still going to deal with radicals and exponents, but in a little bit different way than our last class examples did. In our last class examples, we were converting between mixed radicals and entire radicals, but the radical symbol and the radical sign still stayed there. It was just whether we had a coefficient out in front and it was a simplified radicand, or whether it was a more expanded out radicand. This time, we're actually going to either remove the radical sign altogether, or we're going to introduce it depending on the question. So just to remind you of a few rules, we have an index of A, and if we took the index of A, which is the 8th root of B, we could rewrite that as B to the power of 1 over A. And also if I had something like mth root of x to the power of n, or something along those lines, I keep my x there the same. I have an n, and my index becomes the denominator of my actual exponent fraction, okay? A rational exponent, we call it. Okay. So if we have the cube root of 18, we could go directly to this form of 1 over, or we could just recognize that 18 to the power of 1 is just still itself. So I could actually rewrite this as 18. That's the radicand, it becomes the base. I have whatever's underneath that radical symbol. With the n, we could keep on the numerator. In this particular case, we had nothing, so we're going to put a 1 on top, just like we've done here. And the index becomes the denominator of our rational exponent. So the cube root of 18 is the exact same thing as 18 to the power of 1/3. Moving on to 14 to the power of 1/4. Okay. Our base right here becomes the radicand. So 14 is kind of the big number in both cases. We keep that big number the big number. Whatever was on the top or the numerator stays right there with the 14, and whatever was on the denominator becomes the index of our actual radical. So this is going to be the 4th root of 14 is the same thing as 14 to the power of 1/4. Next, we've got 3 multiplied by the 4th root of 6. Now, 3 is a coefficient, just as in a mixed radical from our previous lesson. I'm going to leave 3 alone. What I care about is getting rid of this radical sign. Okay, so I can see I've got 4 as my index. I could put a little 1 in here, so I could rewrite this as 6 multiplied by the power to the power of 1/4. But I cannot multiply 3 and the 6. This is as simple as it possibly can get. We have a coefficient here. We actually keep that coefficient here. They're not the same base, and we cannot multiply those two things together. Okay, let's look at 5 multiplied by 4 to the power of 1/3. It says now we want to write this as a radical. Again, we have a coefficient. We don't get to change that coefficient. It just gets to hang out in front. It's the 4 to the power of 1/3 that we would like to change. In this particular case, we're going to turn that base of a 4 into the radicand. I can see I've got a nice little 1 on top, so I don't have to put anything, or you could put a 1 where the 4 is, and the denominator becomes the index. So 5 multiplied by 4 to the power of 1/3 is the same thing as saying 5 multiplied by the cube root of 4. Next one, I'm just going to move that over here. I've got the cube root of 3 squared. Okay, so that's that second form where we actually have a number underneath here. Now, lucky for us, the base stays the same. We know we're going to go into a fractional or a rational exponent here because of the square root sign, or the cube root sign, sorry, whatever radical sign we have, it automatically becomes a fraction. The index is always going to be the denominator, and we've got 3 squared up here, so I'm going to keep the square as my numerator. So the cube root of 3 squared is equal to 3 to the power of 2/3. Okay. The last one, we have 5 to the power of 0.75. Well, I don't like that decimal, so I'm going to change it. I know 0.75 is the same thing as saying 3/4, or 75 cents is the way I like to think about it in quarters. Makes it a lot easier to deal with. So I have a 3 and a 4 as my rational exponent. My 3 is on the numerator and my 4 is on the denominator. So I keep my base the same. It becomes my radicand. My denominator becomes my index, and my exponent stays there. And I get 5 to the power of 0.75 is the same thing as the 4th root of 5 to the power of 3.